some placement of things on the periodic table. We have groups numbered, and they start with 1, 2, and then they go 3, and they go all the way to 12. And then they'll call 13 through 18 up here. So if I say group 16, what element is the top of group 16? Oxygen. Okay? Or if I say group 12, what's the top of group 12? Zinc. So it's kind of like a map. You guys have probably never used this ever, but on maps, when you open them up, they'll have I don't know which way it goes. I don't know if it's A, B, C, D, E, F, G regions across the top, like a state of Nebraska map. You know, ones you used to use when you would drive around instead of now your phone and Google Maps. And then on the left side, they would have like 1, 2, 3, 4, 5, 6, 7. And so they say, if you had to look up a city, I need to go to this city, they'll say, look up G7. And so you go G7. Oh, there's where it's at, and you go find it. So on this, it's kind of like we want to talk about group 16. You go, okay, I know where group 16 is. That's oxygen's group. Okay, oxygen, and then sulfur down below it, and some other elements. So those are groups 1 through 18.
Can I get to that vegetables?
So now we'll look at different areas of the periodic table. And one of the things we look at is we look at groups 1, 2, 13 through 18. That's known as a different type of group. So I'm going to go ahead and then just show you that we're going to go ahead and look at this group here. And these are called the representative elements. So, groups 1 and 2, and 13 through 18, these are called the representative elements. Okay, because representative elements are the ones we do a lot more work with than all the other elements. So now, what's not included in that area would be this middle section. Okay? And that middle section is known as the transition elements. They transition from the representative elements. So they have a little bit different characteristics than when we look at the representative elements. So those are called the transition elements. Three through 12. That's what they're going to be, 3 through 12. What the transition elements are. Now down below, these kind of sneak in. If you notice, this is 57 through 71. So, okay, well, where are 57 through 71? Well, they come down here. And that's where they're at. They kind of would slide up into that section and would be between barium and hafnium. You'd have all of these. But they're not going to put them in there because it'll make the periodic table way too wide. And the same for this actinium. Okay, would be the same way. So those are called the rare earth elements. We've got an industry in town. It's called rare. I think it's rare. I'll have to. But it's out by the hospital. You know that building that's out by the hospital would be to the
north, isn't it?
It's to the north of the hospital, but then also west of 77, down a ways. I think it's called rare earth salts. And rare earth salts, what they do is they try to get samples that come in where they've already went through the sample and they're going through it in a different way and getting more of those rare earth elements isolated. And so it's an industry. And rare earth elements are a little bit more they're more expensive, okay? It's just because they're harder to find. And so they're trying to get a niche within the industry in which to isolate rare earth elements because they're used in a lot of with technology, with phones and some different things associated with that. They need those elements. Right? So this first row is called the lanthanide series, or called the lanthanides. So, and then this row is called the actinides. Because they start with lanthanum and actinium. So it's called the lanthanides and the actinides. When you take a look at those, the rare earth elements. Okay? All right. We're also going to switch gears here, and we're gonna show you some families. So periods go across. So as we go across the periodic table, if we go from left to right, and we go across the row, that's called a period. If we go up and down, those are called groups. So up and down are called groups. Going across are called periods. Okay? So if we would go across, these are called periods, going across. Okay? And if we're going up and down, those are called groups. If you want to redraw this sometime, it gets kind of messy. It's kind of up to you. But groups are up and down. Periods go across. Now, there's some families that are also called groups. And those families, the four families we need to know a little bit more about because they have similar characteristics. One's called the alkali family. I like this family. The alkali metals. They are explosive. They are very unstable. Okay? Don't want to be around these guys. They are explosive and unstable. Anytime they could just lose it. Alright, depending upon what's present. Water's present, better back off. Okay? Because they are explosive in water. Okay?
Sodium will explode in water?
You bet.
No.
Okay? Not the sodium chloride when you think of salt, but sodium solid, pure metal. Yep. Alkaline metals, they're related to the alkali, or alkaline earth metals are kind of related. They're right beside them. They're kind of like a family that's similar. They're called the alkaline earth metals. Alkaline. And they're called the alkaline earth metals. They're similar in reactivity to the alkaline metals. They're just not as explosive. They can handle themselves. They are fairly reactive, but they're just not as explosive as the alkaline metals. Now, there's a alkali means base former. So when they react with other things, they form what's called basic solutions. So these elements will form salts that a lot of time those salts will form a basic solution. Okay, so alkali or alkaline, if somebody says alkali and you look it up, it's probably something that's related to some ground, maybe alkali soil would be too basic of a soil and things don't grow well in it. Okay? So then, the other two you probably know a little bit about too is called the halogens. The halogens are all kind of have a color to them, and they're all poisonous. Okay, so the halogens, like, I don't want to mess with the halogens because if I accidentally breathe some of them in, because they're gases, I'm probably not going to feel very well, and it could be something that can really hurt my lungs. Chlorine gas. Okay, bromine's really nasty stuff. Iodine gas. Okay, fluorine.
What do we use iodine for?
Iodine's used as a disinfectant if they dissolve it, like in an alcoholic
Can
solution.
you put in like water to like treat water?
Yeah, and it kills bacteria.
So we can ingest it, but we can't like smell it.
Well, I'm just saying as a gas. If it's in a gas form,
Oh, gotcha.
then what will happen? And a lot of times those are mixtures and they're diluted down. Okay, like chlorine in the water, it's diluted down, you know. But if you breathe the chlorine gas in, 100% of it, that's where we have issues. And then this last one's called the noble gases. I don't know why it does that. It has a mind of its own.
So 13 through 17 are all halogens then?
No,
Or just 17?
just 17. Just that group. Okay. So, last thing is we will do a lab starting tomorrow. In the lab, you're going to have 8 different elements. Those 8 elements, what you're going to do is you're going to go through a series of tests to check out their physical properties and if they change chemically or physically. Okay? Like one of the tests, you're going to test if they conduct electricity or not. You guys have already used the conductivity meter, right?
Yeah.
So each one of those you're going to test. Does it conduct electricity, yes or no? Okay? Then you're going to go ahead and say, well, does it... can I shape it in any way? If I try to hammer it in that, will it break apart or will it kind of stay together? So you'll do that. You'll test to see if it dissolves in water or not. Okay, if it reacts with an acid. We'll give you some, we'll use those microwell plates. We'll see if it heats up. Does it have a low, middle, or a high melting point? Okay, so you'll do a variety of different things to it, and just to kind of see the characteristics that you have in those elements. So, what you'll do is you're going to have to know if it's a metal, non-metal, or metalloid, basically. You're going to have to decide. So, we have this, what we call a staircase, all right? And that staircase, I'll show you what it's going to look at. Just kind of wait here, make sure I'm able to do my staircase right. So here's aluminum, and it's not included in what I'm going to put X's here.
I didn't think there was one of 7 in the halogens for the staircase.
On the staircase, there is acetine.
Okay, what is that, AL or AR?
Al. That's aluminum on the periodic table. Okay, so we have these 3 regions that I'm gonna go ahead and circle with different colors. Okay, the first region is going to be here. That one included. And they have all similar properties. They all have similar properties. Does anybody know what that whole group, what's in common with them? What do we call that whole group of elements there?
Metals.
Metals.
Yeah.
So this whole group here is called the metals. Okay. What do they have that's similar in characteristics? Well, metals are usually malleable, meaning that you can bend them and they won't break. They're ductile, you can draw them into thin wires and they won't fall apart. Okay? We know that electricity flows through metals pretty easy. The electrons are not bound up. And so the electrons are able to go, we'll move through the electric current for you. And they'll do that. We also know that they heat up fast and cool down fast. They will take heat away from your body real quick. So if you grab something metal at room temperature, it feels cold. You ever notice that? This piece here, something that's metal, if you grab it, and it's the same temperature as everything else in the room, and you grab it, it's like, oh man, that's cold. It's not any different temperature than the rest of the room. What's happening is it's such a good conductor, it's pulling heat away from your body right away. Does that make sense? Okay. So it's a good conductor of heat. Okay. And so those are some general properties of metals. So then we've got this middle section of X's. Okay? And that middle section of X's, those are metalloids. So they're not like a metal, but they are like a metal. They do conduct electricity, but they don't conduct very good. They are kind of shiny, like metals. Metals are shiny and they have a luster. Metalloids are shiny, but they don't probably have the same effect as metals do. Okay? They're kind of brittle, like non-metals. But they're probably harder than non-metals would be. Okay? So they have characteristics of both groups. So that's... And you know where they're at because they're right along the staircase. Because you start your staircase at boron and just kind of make a staircase down for the elements. And they all work down to be on that staircase. Okay? And then the last group that we would have is this group right here, and there's not many of them. Okay, and then that would be your nonmetals. Okay, and then hydrogen up here would be included in that. Okay? So that's kind of geography of the periodic table. Metals, metalloids, and your nonmetals. And then we also have some families that we'll get to specific characteristics of later. But that's what we have on with the periodic table and general characteristics of those type of things. We are in section 4.2 and all those things that we came up with. And like I said, this periodic table came and existed in 1869. So we are in the 150th anniversary. It's kind of like the state of Nebraska. The state of Nebraska was like 1868 or something. We became a state or something, 150 years.
Or 152.
Right. So I think it was about the same time as the state of Nebraska became a state. So